Hello, grade 7 students. This is a mathematics lecture. It's lecture 4 for this week. This lecture also is not a new lecture in math. We have seen this lecture last week and we are just revising them. The title of our lecture is Reduction of Fractions. What are the objectives of this lesson? Number one, identify the fraction form, which is numerator over denominator. Number two, identify equivalent fractions and how to get them. Three, reduce or simplify a fraction using different methods: method of successive division, method of GCD, and method of prime factors. 4, perform operations on fractions, addition, subtraction, multiplication, and division. What is the fraction form? To write a fraction in math, we will be writing numerator over denominator. So when I read this line between the numerator and denominator, I read it over. The general form of a fraction is always A over B, where A is the numerator, it's a number, and B is the denominator, and it is a number. Let us talk about special fractions. Sometimes I have a fraction which is A over 1. For example, I have 3 over 1, which is equal to A, equal 3. 5 over 1 equals to 5. 7 over 1 equals to 7. 15 over 1 equals 15. Another fraction, when I get a fraction 0 over B, for example, 0 over 3, 0 over 6, 0 over 9, my answer is always 0. So I don't leave it as A over 1, I write it A. 0 over B, I write it 0. A over A, when the numerator is equal to the denominator, my answer is always 1. For example, 5 over 5, 7 over 7, 10 over 10 is equal to 1. A over minus 1 is equal to minus A. 3 over minus 1 is equal to minus a 3. 5 over minus 1 is equal to minus 5. Any fraction, a number over 0 or A over 0, in math, this fraction does not exist. It's not defined. Number 2, what are equivalent fractions? Here I will have fractions. In between these two fractions, there is an equal. How do we find equivalent fractions? So if I'm given a fraction and I want to find equivalent fractions to it, either we multiply or divide the fraction, numerator and denominator, by the same number. So if I divide the numerator and denominator by the same number, I get a fraction. So these two fractions are equivalent. For example, 7 over 9. I multiplied 7 in the numerator by 3, it gives me 21. 9 in the denominator by 3, it gives me 27. So how did I get a 21 over 27? I get it from fraction 1, which is 7 over 9, by multiplying up and down by the same number, and in between there is an equal. So we say the two fractions, 7 over 9, 21 over 27, are equivalent fractions. Now, the fraction 24 over 64. If I divide 24 by 8 and 64 by 8, I get the fraction 3 over 8. Then the two fractions, 24 over 64 and 3 over 8, are called equivalent fractions. Now, how can we simplify or reduce a fraction? To simplify or reduce a fraction, what does it mean? It means we are making our fraction smaller. And everything I make it smaller in math, it means I'm dividing. What are the methods or the ways to simplify or reduce a fraction? Number one, method of successive division. I will be given a fraction. What I do is to use or apply the method of successive division. I try to divide the fraction, numerator and denominator, starting from 2 and so on. How do I do this? I use criteria of divisibility that we talked about before. For example, 24 over 18. 24, since the 1's 4 is even, and in 18, the 1's 8 is even. So 24 and 18 can be divided up and down by 2. If I divide 24 by 2, it is 12. And if I divide the 12 by 2, it is 9. Now the fraction 12 over 9, 12 can be divided by 3. Why? Since applying the criteria of divisibility by 3, 1 plus 2 is a 3, and 3 is a multiple of 3. 9 also is a multiple of 3, so we can divide up and down by 3. 12 divided by 3 is 4, and 9 divided by 3 is a 3. So 4 over 3 is an irreducible fraction. What do we mean by irreducible fraction? It cannot be reduced anymore. And also, as you can see, since between 24 over 18 and the 12 over 9, 4 over 3, there is an equal. So we call these three fractions equivalent fractions. Also here, I solved an example, which is 120 over 300. I ask, can we divide 120 by 2? Yes, since the ones is even. 300 by 2? Yes, since the ones is even. So if I divide, I get 60 over 150. Also, we can divide up and down by 3. It's 30 over 75. I can no more divide by 2, so I divide up and down by 3. It gives me 10 over 25. Now 10 over 25 can be divisible by 5, and the answer is 2 over 5. These criteria of divisibility I have given you before or reminded you of before, so please memorize and study them. Now the second method is called method of GCD. We have learned together in the lesson of prime numbers, how can we find the GCD of two numbers? We learned that if I have two numbers, to find their GCD, I do the prime factorization of both numbers. Then from the prime factors, I choose the less common factors only that have the least exponent. So what is the method of GCD? I will be given a fraction in which I have a number in the numerator and a number in the denominator. I find the GCD of both the numerator and denominator after I do the prime factorization. Then I divide the fraction by the GCD. 24 over 18, I make the prime factorization of 24, the prime factorization of 18. After that, I choose the GCD of 18 and 24. What do I choose? The common bases with the least exponent. Between 2 cubed and 2, I take 2. Between 3 and 3 squared, I take 3. So if I multiply 2 times 3, my GCD will be 6. Now I divide my given fraction 24 over 18 by 6 up and down, and I get 4 over 3, which is an irreducible fraction. So when I use the method of GCD, in one step I should get the irreducible fraction. And here I have another example that you can apply on draft to understand it more. Now, the third method is the method of prime factorization. What is this method? Also, I do the prime factorization of both a numerator and denominator. After that, I write both the numerator and denominator as prime factors, then divide by canceling the similars between the numerator and denominator. Also 24 over 18, I look here and I write their prime factors, which are 2 times 2 times 2 times 3. The prime factors of 18 are 2 times 3 times 3. Now I cancel 2 by 2, from numerator and denominator, 3 by 3 from numerator and denominator. I'm capped with 2 times 2 in the numerator, which is 4. I'm capped with 3 in the denominator, so I get the irreducible fraction 4 over 3. Also, this is another example for you to solve. Now, there is an important attention. If I'm given a fraction a over b, if a and b are relatively prime, which means their GCD is 1, then the fraction is irreducible directly without making anything. For example, 8 and 15, their GCD is 1, so it's irreducible. 12 over 25 is also irreducible. If the numerator of any fraction is 1, also the fraction is directly irreducible. For example, 1 over 5, 1 over 8, 1 over 20. Since in the numerator I have 1, directly I say my fraction is irreducible. If numerator and denominator are consecutive numbers, numbers after each other's or successive, then the fraction is irreducible. For example, 9 over 10, 21 over 20, 5 over 6, 8 over 7, all these are irreducible fractions. Now, what operations can we perform on fractions? A, addition and subtraction of fractions. I'll be given 2 fractions. In between the fractions, I have a plus or a minus. Here, we have 2 cases. Whenever we are given addition or subtraction of fractions, directly I look at the denominator of a fraction 1 and the denominator of a fraction 2. They are called like fractions if they have the same denominators. Directly we get a result fraction. Its denominator as denominator 1 and denominator 2. Its numerator, we add or subtract numerators 1 and 2. Then the result fraction that we get, it should be reduced to get an irreducible fraction if possible. If I look at the denominator of fraction 1 and fraction 2, they are called unlike fractions if they have different denominators. So we change them into like fractions. How? We multiply all fraction 1 by denominator 2, then we multiply all fraction 2 by denominator 1. Now we are back to like fractions, so we apply what we did above. As examples, 4 over 11 plus 5 over 11. If I looked at these 2 fractions, the denominator of a fraction 1 is 11, the denominator of a fraction 2 is 11. So the result fraction, my denominator is 11, and I add 4 plus 5 is 9. 9 over 11 is an irreducible fraction. 2 over 10 plus 4 over 10. Since the 2 denominators are 10, so these are like fractions, directly I get the result fraction. My denominator of the result fraction will be 10, and 2 plus 4 is 6. 6 over 10 is reducible. Why? Because we can divide 6 and 10 by 2. If I divide 6 by 2, I get 3. If I divide 10 by 2, I get 5. 3 over 5 is an irreducible fraction. Now 11 over 6 minus 2 over 6. The answer is 9 over 6. Also, we can reduce by 3, so I get 3 over 2. Now the case of unlike fractions. 3 over 5 plus 2 over 7. My denominators are unlike since I have 5 and 7. So what I do is I multiply all fraction 1 by denominator 2. So up and down, I multiply by 7. Also, I multiply fraction 2 by denominator 1. So I multiply up and down by 5. 3 times 7 is 21. 5 times 7 is 35. Plus 2 times 5 is 10. 7 times 5 is 35. Now I have like fractions. So in the result fraction, I get 35. 21 plus 10 is 31. 31 over 35 is an irreducible fraction. Also, 1 over 4 plus 5. 5 is a number, so I change it into a fraction. I put it over 1. So always to change any number into a fraction, write it over 1. Now, since the denominator of the first is 4 and the second is 1, so I should change them from unlike fractions to like fractions. So I multiply only fraction 2 by 4 up and down, since if I multiply fraction 1 by 1, it will give me the same fraction. Now I have like fractions, so my denominator is 4, and I add 1 plus 20 is 21. The same case applies to subtraction of unlike fractions. Please apply these examples well on draft to understand the idea well. Now, multiplication of fractions. I'll be having two fractions in between, I have times. So directly I get a result fraction. How? I multiply numerator 1 by numerator 2 over, then I multiply denominator 1 times denominator 2. I write it in this way. Now, as an example, 5 over 11 times 3 over 7. Since I have times, so I multiply 5 times 3 and 11 times 7. Now, can I reduce any number in the numerator by any number in the denominator? Is there any common factor between 5 and 11? No. Between 5 and 7? No. Between 3 and 11? No. Between 3 and 7? No. So I multiply. 5 times 3 is 15, and 11 times 7 is 77. Now, 9 over 20 times 15 over 2. Also, since I have times, I multiply 9 times 15 over 20 times 2. Since there is a common factor between 15 and the 20, both can be divided by 5. So I say 15 divided by 5, I cancel it and I write 3. 20 divided by 5, I cancel it and I write 4. No more common factors between the numerator and denominator. So 9 times 3 is 27, 4 times 2 is 8. This is an irreducible fraction. Also, this is an example on multiplication. You can practice it on draft. Part C, division of the fractions. There will be two fractions and in between divided by. There are 3 steps here. First, we write fraction 1 as it is. We change in the second step division into times, and we find the reciprocal or the inverse of a fraction 2. What do we mean by reciprocal or inverse of a fraction 2? Reciprocal of a fraction, we flip or switch both numerator and denominator. Then here we are back to multiplication of fractions. For example, 4 over 7 divided by 9 over 2. Since we have division, so we apply the steps. We write the first fraction 4 over 7 as it is. We change division into times, and we flip 9 over 2. We find its reciprocal or inverse. Numerator becomes denominator, denominator becomes a numerator, it becomes 2 over 9. Now we are back to multiplication. So we write 4 times 2 over 7 times 9. Is there any common factor between the numerator and the denominator? No. So we multiply, it's 8 over 64. Also here we have 2 exercises you can practice alone. This was our lesson for this week. Please watch it well, as I always say, and if you have any question after watching this video, please contact me. Thank you.